Good afternoon to everyone. So today topic is in our first semester, Earth. Okay, about the Earth. Right. So Earth, all of you know about the Earth. So in our solar system, we already discussed about one of the planet in solar system, right? So the Earth is a unique planet, right? So it homes to millions. So it is the only planet delicately balanced by the conditions that is necessary for our sustaining life, right? So the Earth we live on has fascinated the mankind since the beginning of the civilization. So you are aware that the earth has provided us everything. So we require, think, or imagine. So it is therefore referred to as the mother earth, right? Mother earth. So we have always been curious to know about this planet, that is Earth. So on which our forefathers lived, right? So you recognize that since times, so immemorial man has been questioning what is that? About its shape, size, and extent and position in the space besides different kinds of the surface features of the earth and the process is working on it, right? So since the time of earlier, some of the philosophers to the present day scientists, we have acquired some knowledge about our planet, that is earth. So, however, there is always a scope and need of new ideas and views as no knowledge is complete and final. So, one of the branches of science dealing with the study of earth is geology, right? What is that? Geology. Sorry, geology. So now we are going to next slide. So this is the origin of the earth. So, so you may have in our mind several questions in your mind, right? So about the earth, like how old it is and how did it form, right? So man has always been interested to find answer to these questions. What is that? How old it is and how did it form? What is the earth, right? So our present understanding about this origin of the earth and its evolution has not come at a shot, but in bits and pieces with continued research over a long period of time by different researchers, and it has matured with time, right? So let us now study in this section how the earth was formed and about the different hypotheses and theories, so which have been proposed by different researchers or different scientists, right, while trying to explain origin of the earth, right? So we have discussed in previous section, that is solar system, right? So the earth along with other planets, right, it has a common origin that is described as solar nebular hypothesis, right? Solar nebular hypothesis. So majority of the scientists agreed that the Earth and the solar system, those were formed by the planetesimal accretion, right? Planetesimal accretion and gravitational contraction of a massive nebula. So the cold primitive Earth became gradually heated to compression by the increasing weight of accumulated matter and the decay of natural some of the radioactive materials, right? So when heat was produced quicker than it could escape, so it resulted in melting of some constants, right? So heavier matter were drawn towards the earth centers due to gravity, right? Gravity. Gravity and the core formed surrounded by the mantle of less dense material and outer crust, right? So I will explain briefly in next class about the interior of the earth, right? So many hypotheses and theories have been proposed to explain this origin of the earth and other related planets that can be broadly divided into two types or two groups. So first one is uniparental or monistic hypothesis, and second one is biparental or dualistic hypothesis, right? So uniparental, what is the uniparental hypothesis? So this group of hypothesis is based on the assumption that the origin of the earth that is related to the systematic evolutionary process from one parent body. Remember this, only one parent body. One parent body. One parent body. So it has been favored by the Kant, Laplace, Lockyer, Hoyle, Carl Wiesecker, and Harold Urey, and Kupikars, right? So this is the uniparental hypothesis. And next we are going to biparental. So biparental in this group of hypothesis is based on the assumption, right? Based on the assumption that is two parental bodies. This is this is one parent body, and biparent means two parent bodies, right? Two parent bodies were involved in this formation of the earth, right? So according to these hypotheses, the earth and other planets have been formed as a result of some explosion activity, right? Explosion activity. So
Big Bang
now,
Theory, ma'am.
yes,
Big Bang Theory.
Big Bang theory. Right, right. So now we are going, next slide. I will tell that Big Bang theory. Okay. So it is supported by, you see here, Buffon, Chamberlain, and Moulton, James Jeans, Jeffrey, Russell, Latland, and Banerjee, and also others, right? So these are the origin of the earth, that is two groups divided into uniparental and biparental. Now let us discuss briefly some of the popular hypotheses proposed to explain the origin of the earth. You see here. First one is Kant, right? So nebular hypothesis of Kant. In the year of 1755, the German philosopher, right? German philosopher Immanuel Kant suggested that the origin of the solar system, it could be traced to a rotating cloud of gases and fine dust. Fine dust, it means a particulate matter, PM10 or PM2.5, like that, right? So the fine dust known as nebula, and the idea was called nebular hypothesis, right? Nebular hypothesis,
Hypothesis.
right? Just wait, this is touch screen. Hmm. So according to his hypothesis, Kant hypothesis, the solar system evolved from a single large flat and and rotating nebula that extended beyond the position of the most distant planet, right? So the rotating nebula, according to the law of universal gravitation, so became more compressed and compact with an increase in the speed of rotation, right? Speed of rotation. So as this nebula contracted, the mass became concentrated towards the center, right? Center. So this led to an increase in rate of rotation and a growth of centrifugal force, right? So the particles of matter fell upon one another under mutual gravity attraction. So it generated heat, right? Heat and imported rotation to the parent mass. So in this way, the original cloud became a hot spring masses of gases. It's called nebula. So he suggested, who suggested? Kant. Kant suggested that the eight planets including the Earth formed from the world, its equatorial plane, right? Equatorial plane. So, so the evolutionary theories uh, about Immanuel Kant. So some of the article, right? Some of the article is the general natural history, the general natural history and the theory of the heaven, or the essay on the working and mechanical origin of the entire universe. So this is the article name. So this was presented in the 19, in the year of 1755 by the German philosopher Immanuel
Immanuel Kant.
Kant. Right. Okay. So what is the evaluation of Immanuel Kant theory? So his hypothesis was criticized by the scientist and considered it baseless, right? So as he was not able to explain the source of the origin of the primordial matter. So at last it was disapproved. So the Kant did not explain the source of energy to cause the random motion of cold matter. So which was motionless in the initial stage. So the rotatory motion can never be generated in the collision among the particles of the primordial matter. So it is an incorrect or wrong statement of mechanism. So the Immanuel Kant consideration was against the law of conservation of angular momentum, that the rotatory speed of the nebula increased with the increased of its size. Okay. So this is
Okay,
the
ma'am.
Kant nebular hypothesis. And next one is nebular hypothesis by Laplace. So in the year of 1796, the Laplace suggested that due to contraction and condensation of the gaseous nebula, velocity of the hard gases, spinning nebula, that is increased tremendously. So the centrifugal force became more than the force of addition, right? So hence a ring of gaseous matter was throw up. So this ring segregated to form one planet, right? One planet. So repetition of such event gave rise to other planets, and the central part remained as the sun. So the solar system was formed from spinning cloud of gases. It means nebula, right? So it is a famous concept of French mathematician Marquis de Laplace. So full name is Marquis de Laplace. 1796,
96.
right? Hmm. It is only updated version of the hypothesis of this
Immanuel
Immanuel
Kant.
Kant. So he told that with gradual cooling, the nebula shrank and started spinning even more rapidly. So the motion of spinning caused nebula to flatten like a disc shape, right? So the originally the sun was a giant cloud of gases. It means nebula, right? So that rotate even. So it was firm belief by him, right?
Yes,
Then
ma'am.
to gravity and cooling. Due to gravity and cooling, the gas gets contracted. So which forced gas to rotate faster, right? So it threw off a rim of gas or ring of material separate, which condenses later. So several times, this process would be repeated to produce all planets, right? So the remaining ball of gas left in center and became the sun. So the evolution of this Laplace hypothesis, the source of origin of nebula, it was not described by Marquis de Laplace, and also he was not able to explain the following formation of fixed number of planets, that is 9 planets, our solar system, right? So as started by all the satellites, so should revolve in the direction of their father planet, but differently to this. So satellites of Saturn, right? Saturn and also Jupiter revolve in the opposite direction of their father planets, right? So this is the nebular hypothesis by Laplace. And next we are going to planestimal hypothesis by Moulton and Chamberlain, right? So in the year of 1905, okay, what okay, 1905. So according to this, as another star approached the sun, so huge tides are filaments of hot gases, those were pulled out from the sun. So as the star passed, these arms of gas were given the rotational motion. So after the star was gone, the gaseous matter in these arms condensed into solid material and gradually due together to form planets, right? So this is the planetary hypothesis by Molt and Chamberlain. And Jeans tidal theory. Jeans and Jeffrey. So first of all, we are going to Jeans tidal theory. So this theory was given by the Jeans in the year of 1919, right? So the tidal effect was made on the sun by a passing star, right? So the cigar shaped projection came out of the sun due to gravitational attraction of the passing star, and this formed the parent body, right? So from the cigar-shaped filament planets, these were formed on cooling and condensation. So this is the Jeans theory and Jeffrey collision hypothesis theory. So this hypothesis was proposed by, who is that? Jeffrey in the 1929, right? 1929. So according to him, there was a collision between the sun and passing star. Sun and passing star. So passing star, a glazed surface of the sun, which resulted into solar matter coming out, right? So he suggested that planets were formed by condensation of this solar matter, right? So the tidal theories of the Jeans and Jeffrey. So British scientists, these are the British scientists, Sir James Jean is the British scientist, right? So proposed is tidal hypothesis. So to explain, what about the origin of the Earth in the year of 1919? So while Harold Jeffrey, full name is Harold Jeffrey, another British scientist is also, so he gave an idea of modifications in the tidal hypothesis, right? So as said by Sir James Jeans, the solar system was formed from the sun and other including stars, right? So in the beginning, the sun was a big incandescent gaseous mass of matters, right? So besides the sun, so there was another star named as intruding star, right? So in the universe. So this is the Jeans and Jeffrey hypothesis. So figure not coming here. Okay, we'll upload later. So now, oh, there were some of the modifications is there. So that is Jeffrey the hypothesis, and so the evaluation of Jeans and Jeffrey theories. What is the evaluation? So the explanation of whereabout and density of the intruding star, it was not explained by James Jeans, which caused tidal eruption on the surface of the primitive sun in the form of a filament, right? So as on the base of some of the mathematical calculations, the tidal hypothesis fails to explain the real distances between the sun and the planets in our solar system. So the planets of our solar system are largely formed of the elements having high atomic weight. So, but the constituent elements of the sun, those are of lighter atomic weight, right? So the hypothesis failed to offer convincing explanation for such unusual situations. So the Jeans was not able to elaborate the process and mechanism of the condensation of matter ejected from the primitive sun, right? So now we have some modern, this is our modern views. So you see here uniparental and biparental, already I told about this. So uniparental view of origin by evolutionary process, it has been much favored by mathematicians, astronomers and physicists, chemists and also geologists, right? So the Carl Wiesakers, you see here, so it was proposed in 1943. It was modified by Harold Urey in the year of 1952, which was further revised by Cooper in the year of 1957. Right? So first one is Urey Cooper hypothesis. So according to this hypothesis, there was a big cloud of dust and gases in the space, right? So it constituted a mixture of condensed water vapors and also ammonia and methane, like hydrocarbon gases and iron oxide dust, right? So by the effect of flight of stars, compression started in the components of this big cloud. So this led to central part of the cloud to develop into ancestral sun. It's called ancestral sun. Sorry, pen is not working here. Okay. This one, ancestral sun. So by the process of condensation. So in due course, the huge cloud of gas and dust that is rotating around this ancestral sun also divided into turbulent eddies of uneven sizes. So according to this Cooper, as the distance from the sun increased, size of the eddies increased. EDDI is eddies increased. So they collided with one another and formed planetesimals, right? Planetesimals. That means small planets, right? Or protoplanets started by uniting and condensing. So by collision and union of planetesimals, larger planets were formed, right? So one of these is our Earth, right? That is, we are leaving there. So after melting, the differentiation started in the components of the earth. After formation of the earth, various type of gases were ejected from its interior, and from these gases originated the atmosphere. So this is the Uri Cooper hypothesis and Fred Hoyle's magnetic theory. The Fred Hoyle in the 1958 proposed is the process of differentiation of the sun from an original nebular matter. So that had been undergoing contraction. So the differentiation of the nebular matter into sun and the gaseous cloud, it was due to fast rotation of the nebular mass, right? The process of differentiation came to an end due to magnetic coupling between the sun and gaseous cloud and gave rise to planets, right? So some of the Indian physicist, you see here, this one, Jayant Narlikar, right? Jayant Narlikar is the Indian physicist. He proposed a theory together with Fred Hoyle, which is known as Hoyle-Narlikar theory. So it was motivated by their belief in the steady state model of the universe, right? Next, we are going to Big Bang theory. This is also very important. So Big Bang theory, it means currently the Big Bang theory is the best model proposed to explain the, what about origin of the air, right? Origin of the air. So it states that the universe emerged from a hot and dense state billions years ago. So from this soup of elementary particles means electrons, protons, neutrons, etc. Right? So all the elements that we know today in the periodic table were formed, right? All of you know about this periodic table, right? So the Big Bang nucleosynthesis theory attempts to explain the related process. So the Big Bang nucleosynthesis occurred only in first 3 minutes. First 3 minutes. So the universe has been expanding ever since the creation. Creation, which is called Big Bang. Which is called Big Bang. So the theory was propounded first by this George, right? George Gamow. George Gamow in the year of 1940s. In 1940s, and details were worked out by Fred Hoyle and William Fowler, right? William Fowler. The term Big Bang was coined by famous English astronomer Fred Hoyle, right? Fred Hoyle. So there was a course, no bang or explosion signaling the beginning of the universe, but it was certainly a violent event. So since all the matter and energy in the universe today, it was created at that point instantaneously. So some of the astronomers believed that this event took place around how much? 14, right? It's okay. So 14 billion years ago, the Big Bang theory has been remarkably successful in explaining several observations about the universe, right? So various planetesimals in our solar system gathered enough material together to form Earth and other planets about 4.6 billion years ago, right? So the Earth has been evolving, the changing ever since its origin, right? So it is believed that this early Earth was probably cool, right? So composed mostly of silicates with compounds of silicates and oxygen, iron, and magnesium oxides, and also some other elements in small amounts, right? So it had generally uniform composition and density throughout. So in the first tens of millions of years of the Earth evolution, combination of several factors you see such as first one is impact of small bodies like meteorites. I already told about these meteorites in previous class, and gravitational compression. And third one is squeezing together of matter. And fourth one is heat from radioactive decay, increased temperature of the earth, right? So the temperature increased enough to cause some of its constituents to melt, resulting into disappearance of homogeneous composition and replacement by a series of concentric layers of varying composition and density. So this changed the earth in a some of the differentiated planets consisting of three concentric layers, that is crust, mantle, core. All of you know about that. So we shall discuss about these layers in this unit later. Okay. So now this is the Earth evolution, and now we are going to age of the. So what is the age of the Earth? Anybody? Sanjay, వింటున్నావా? Okay, right. So age of the Earth is okay, right. So 4.54 billion years or 4.5 billion years. So some of the scientists calculated how old planet Earth is by subjecting iron meteorites. So that has previously hit the planet to radiometric dating techniques, right? So they assumed that all bodies of the solar system, including Earth, it formed simultaneously and thus most likely have the same age, right? So therefore, some of the scientists could use samples from other objects in the our solar system to estimate how long Earth has been around. So life on Earth in the form of microbes only began about 3.7, right? 3.7 billion years, 3.57 billion years ago. So the chemical analysis of rocks in Greenland it revealed a type of carbon molecule, a trace of these earliest microscopic organisms, right? So stromatolites fossils. So, and structures formed from sediment wrapping and binding of cyanobacteria. It means blue or green color algae. So those are an essential source of information on how early life developed uh, on Earth. So the oldest known stromatolites fossils found in Western Australia, it has been dated at 3.45 billion years ago or billion years old, right? So what is the earth of the age? What is the earth of the age? 4.554 or 5 billion years ago. So now size and shape of the earth. So it was believed that the earth was flat before. Earth was flat and that ships could sail over the edge. So this view, you see here, this view persisted even in the Middle Ages, and it was an issue in the recruitment of Columbus. Columbus అనే అతను మీకు తెలుసు. Columbus. ఇండియన్ కనిపెట్టింది ఎవరు? కొలంబస్సే కదా. సో కొలంబస్. సో ఎర్లీ గ్రీక్ వ్యూ, ఇట్ వాస్ దట్ ద వరల్డ్ వాజ్ సరౌండెడ్ బై ది what was that? Oceans, right? And origin of all rivers, oceans and origin of all rivers. So Anaximander, Anaximander. He is live in 16 and 600 BC. He is proposed that the cylindrical earth was surrounded by celestial sphere, right? So, and also Pythagoras సిద్ధాంతం అనేది మనకు చిన్నప్పుడు చదువుకున్నాము. So Pythagoras, he believed that the earth was a sphere, right? So which was considered the most harmonious geometric shape, right? And also Aristotle. So Aristotle described observations that supported the theory that the earth was a sphere. So these included the fact that the shadow of the moon is circular in lunar eclipses and the constellations were higher in the sky as one traveled south area, right? So you see, this is the picture. This is the geode shape of the earth, right? So Eratosthenes, Eratosthenes, he is the scientist. His estimated size of the earth from observations that the elevation of the sun varied with position on the earth's surface in Egypt. So some of the observations of the earth is a sphere. So that is, first one is mountain peaks lit by the sun after sunset, and also ships disappear below the horizon as they sail across oceans, and also the moon looks like a disk, right? So the, and also last one is the earth casts a circular shadow during lunar eclipses. So the earth is an oblate spheroid. It blotched at the equator and flattened at the poles. Poles means south poles and north poles. We have south poles and north poles, right? So it is called geode. Is that Geoid, geode, right? So it means the earth is earth shaped, right? That means earth is earth shaped. So the bulge at the equator is caused by the centrifugal force of the Earth's rotation. So the gravitational pull of the Earth is the strongest at the flattened poles. And flattened poles means South Pole and North Poles, right? And it is weaker towards the equator. Okay? Equator. So, so this is the shape and size of the Earth. Now we are going to interior of the Earth or internal structure of the Earth. So the deepest hole in the Earth is only about how many kilometers there? 8 kilometers. 8 kilometers. So this is quite negligible in comparison with radius of the Earth. The internal structure of the Earth is based on the existence yielded by indirect geophysical method. It's called seismic methods, right? Seismic method is, this is also very important. So the earth body comprises of several layers. All of you know what is the layers, right? Several layers which are like shells resting one above the earth. So the layers are distinguished by the physical and chemical properties, right? So the interior of the earth has been obtained from the study of earthquake waves through the earth. So there are three types of waves. All of you know about this. So first one is P waves, and second one is S waves, and third one is L waves. Right? So P waves, it's called primary waves, right? So these waves travel in solid, liquid, and gaseous medium, right? And they have short wavelengths and frequency. And S wave also called as secondary waves, right? So these waves travel in solid medium and they have short wavelength and high frequency. And L waves are surface waves. It's called surface waves or Rayleigh waves. So these are transverse waves and confined to outer skin of crust, right? So these L waves responsible for most of the destructive force of earthquake, right? So the shell of the increasing density, those are found towards the center of the center of the earth is how much? 8 GCC. So each cell is formed of different materials on the basis of seismic investigation. These waves, right? Seismic investigation, the earth interior has been broadly divided in three types. So that is this, this is the crust, and this is the core, sorry, this is the mantle, and this is the core. Crust, mantle, core. So what is the crust? Crust is the near surface layer. So with variables, thickness is how much? 5 to 50 kilometers, right? So the crust in the oceanic region is considerably thinner than the crust in the continental region, and it is remarkably homogeneous with a thickness of 6 kilometers. So it construct the thickness of continental crust is highly heterogeneous. So it can be also divided into two types. So that is upper layer and or upper crust or lower crust, right? So upper crust is called continental. These are the continental, this green. So continental crust and oceanic crust. This is the upper crust and lower crust. It's called continental crust and oceanic crust. So the upper crust is also called Sima, sorry, Sial. And lower crust is also called Sima, Sial and Sima. So what is the Sial and Sima? Right. So Sial means this is the upper continental crust, right? So it consists of all types of rocks. It means igneous rocks and sedimentary rocks and also metamorphic rocks. So this layer is rich in silica and aluminum. That's why it's called Sial, S-I-A-L. S-I means silica, Al means aluminum. That is Sial, right? So the rocks are granitic and granodioritic composition, and the density of Sial is 2.4 grams GCC, right? So the Conrod discontinuity, you see here this one, Conrod. Okay, this Conrod discontinuity, which is located at the depth of 11 kilometers, right? So this is Sial in the continental crust and Sima. So this is the lower continental crust, right? So thickness of this 123 kilometers extend from the this corner discontinuity up to this Mohovisic discontinuity, right? So this layer is rich in silica magnesium. That's called SIMA, S-I-M-A. S-I means silica, M-A means magnesium, right? So the types of rocks are basaltic composition. So in Sial, what are the types of rocks is there? Granite and granodioritic, right? And in CMOM, the density is the 3 G for CC, right? So this is the Cl and CMA or upper mantle and lower mantle. Sorry, upper crust and lower crust. And next we are going to second part of the layer, that is mantle. So this part, right? This red part, okay? This red part. So the mantle is the thickest of Earth's layer and takes up how much? 83% of the Earth's volume, right? So it extends down to about how much here? Here last to 2900 kilometers from the crust, right? 2900 kilometers from the crust to Earth's Earth core, and it is largely composed of a dark, right, and dense and igneous rock. So that's called periodolite, right? Periodolite. So it containing iron and magnesium. So the mantle has three distinct layers, that is a lower solid layer and asthenosphere, right? So which behaves plastically and flows slowly. And the solid upper layer, right? So this is also divided into two layers, that is upper mantle and lower mantle, right? So upper mantle in the layer below this moho, you see here this moho discontinuity down to 400 kilometers is referred to as the upper mantle. So it is a hard envelope of semi-molten materials whose top parts are semi-solid. It's called asthenosphere, right? So its general composition consists of silica, is that silica and magnesium. Silica and magnesium rich minerals, that is called SIMA, right? So the outer mantle is usually traversed by huge but slow convection currents that result in fragmentation of the overlying crustal plates. Okay? And lower mantle. So the hard envelope of molten materials and it is general composition consists molten, that is silica plus magnesium rich minerals is there. And also the inner mantle is usually of more temperature than the above shell, right? So towards it's based the short waves. Short waves display its great reduction in their velocities. It's called Gutenberg discontinuity. You see this one, this Gutenberg discontinuity, right? And the core has two layers. Next one is core, right? This is also two layers. So an inner core that is solid and outer core that is liquid, right? So the core is mostly iron with some nickel and it takes up 16% of Earth's total volume. So the core is divided into two parts, outer core and this outer core and inner core. So outer core is very hot and envelope of strongly molten materials. So it is mainly composed of molten sima. It means sima means silica and magnesium. It as well as some of sulfur, nickel and also iron, right? So due to the great overlying pressure, so this part behaves as solid, right? So however, it is a real melt. So the short waves suffer a great reduction in the velocities in this part. And next we are going to inner core. So this is a very hard envelope of strongly molten material, right? And it is entirely composed of molten nickel and iron. So that's called NiFe, NiFe, right? You see here NiFe, nickel and iron. So that is same as meteorites. So due to the very excessive overlying pressure, so this part behaves as solid, right? This is solid. So the short waves displaced increase the velocities in this part, right? So this is very, very important question they're asking in your examination and you can draw this figure and also write about this interior of the earth. So what is the interior of the earth? So that is earth is divided into so earth is divided into three layers, right? Three layers, three layers. So crust, mantle, core. Okay. So crust is divided into also upper crust and lower crust, right? Upper crust and lower crust. And mantle also upper mantle and lower mantle. And core also divided into two layers, upper core and lower core. Lower core, right? So it's called Sial, SiAl, silica aluminum, and it's called Sima, right? You see here. So concord discontinuity. Where is it is concord? So you can write, we have three discontinuities there. First one is concord discontinuity. So it is the between the continental crust and oceanic crust. And moho discontinuity. Moho discontinuity means so oceanic crust and upper mantle, right? So and also Gutenberg. Gutenberg is uh, upper, not upper, inner mantle, right? Inner means lower mantle and outer core, right? Lower mantle and outer core. So these are the very important topics. Three discontinuous: Concord and Moho and Gutenberg, right? And also we have two discontinuous is there. Lehman discontinuity, that is outer core and inner core between the line. That is called Lehman discontinuity. And also here asthenosphere and inner mantle between the line, it's called repetitive discontinuity, right? So you can write like this. So they are giving essay question. Okay. So you should draw this figure. Okay. And you can explain about this interior of the egg. This is must and should question. Okay. So any doubts? Only one student is there, Sanjay Rani. Sanjay Rani, any doubts? Okay, right. So now, so today class is over and next Sunday is the last class, 19th. Okay. Okay.